Alright, let's talk about beat frequency. So if I get two sources of sound, and they're similar, differ by a few hertz, and I make them both make sound at the same time, this sound will start to interfere. The two sources of sound will interfere with each other, and what I get is an alternating loud and soft sound. And you've either heard me do this in class, or you will hear me do it in class, or you watched a demonstration of it on YouTube, and it goes wow, 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 is the type of sound that you get. An example would be two identical tuning forks, and if I put a piece of gum on one of them, it will slow it down a little bit. So which one will vibrate the quickest? This one right here will be the quickest. This one's going to be slightly slower, slowed down by the gum. These tines will not vibrate back and forth as quick. So if a compression and a rarefaction, I'm going to go with black here. I've got the unloaded one, this one, the fast one. I would get compression, rarefaction, compression, rarefaction, compression, rarefaction. As these tines swing out, they would make a little compression here. When they swing back, they would make a rarefaction. When they swing this way again, they'd make a compression. So as these tines go back and forth, back and forth, back and forth, back and forth, they are making compression, rarefaction, compression, rarefaction as they head out. So compression, compression, rarefaction. And I'm trying to put these spacing, I'm trying to make the spacing the same, because they should be the same if this thing continues to vibrate without being interfered with. So, but this guy right here, it's not going to vibrate as quicker. So I might get a compression the first time, but the rarefaction is not going to happen as quickly. It's going to be slightly put off. So what I'm going to do is I'm going to put it here, and then I would get a compression. I'm trying to make the space here 1.5 times the space up here, and then I would get a rarefaction and a compression and a rarefaction and a compression and a rarefaction and a compression. So what would I be getting here? I'm going to get interference. When a compression meets a compression, I would get constructive interference. Here I've got a compression meeting a compression again, and I would constructive interference, and here again. Yes. Constructive interference will be red. But when a compression meets a rarefaction, like here or here, I'm getting destructive. Yes. So this is the reason why I get that wow, 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 wow sound. It's up, high, quiet, high, quiet, high. Wow, wow, wow. Yes, it's the reason why I'm getting these beats being produced. And yes, the distances between the C and the R will be bigger in the loaded fork as it's moving slower, and I did that, whoops, I did that here. I made these distances bigger than on the unloaded fork. Of course, all things physics, we smack a math formula on it. How many beats will I hear every second? It's called beat frequency. It's going to be in hertz. It's the number of maximum intensity points per second. What I do is I take the two frequencies and I subtract them, the two frequencies that I'm dealing with. In this case, it would be the frequency of the loaded fork and the unloaded fork. I would take those two frequencies, I would subtract them. If the answer comes out negative, I've got absolute value bars because I only want a positive answer. Humans, in general, on average, are only capable of hearing 7 beats per second. If it's higher than that, we get our ears can't differentiate and can't pick up the beats. So an application, whoops, jumping around. An application of this is tuning a piano. So what they used to do back in the day is somebody would come over to your house if you had a piano, and my family did when I was younger, and he would have a tuning fork, middle C, and he would play middle C on the piano, and he would hit the tuning fork, which was deemed to be correct, and it would start to they both be the same frequency, hopefully, but if they weren't, he would hear and he would know that they're not the same. Middle C on the piano, middle C tuning fork, and not the same. So what he would do then is he would start changing the frequency of the piano. He would start to change that middle C. He would start to tighten the strings, increase the tension on it, so that the frequency that it was playing it would change. And eventually, when he played the middle C piano key, middle C tuning fork, he would no longer hear beats, and then he would know middle C on the piano is correct. And then he would tune all the other keys, 87, on the piano. He would tune them by ear, and he would, after he knew the middle guy, he would know what this one should be, and this one, and this one, and this one, all the way up, and then he would go all the way down, just using his ear. So it was quite a skill to tune the piano. Nowadays, they've got technology has electric tuners where you can tune, you can play a note and the machine will immediately tell you if you're high or low, and you can change your musical instrument until you get this electronic tuner to tell you that yes, that note is bang on. But yeah, technology has definitely changed how we tune pianos. Let's do 2 questions. Tuning fork, frequency, yes, so I've got 2 frequencies. I've got F1 here, looks to be 440 Hertz. F2 is 437 Hertz. How many beats will be heard over a period of 8 seconds? So I'm just going to use the short form for beat frequency. I know that, whoops, beat frequency is equal to absolute value of F1 minus F2. That would be 440 minus 437, which would be 3 Hertz, which means 3 beats for every second. Now, if the time is 8 seconds, that means that I'm going to get 24 beats in 8 seconds. So there's the first example. One other one here. A beat frequency of 5 Hertz is heard when 2 tuning forks are struck. If one has a frequency of 200 Hertz, what is the frequency of the other one? So I get my, oops. And here's a little trick. What's F2? Now these absolute value bars mean that there's 2 possible answers. How do I get a 5 here, a positive 5? Well, that means in here can be 5 or negative 5. After I take the absolute value, both of them turn into a 5. So that means that F2 could be 195 or could also be 205. Because 200 minus 205 is minus 5, absolute value 5. Boom. So there's 2 answers here. Don't get tricked on an assessment and only give one answer. Here there's supposed to be 2. And that was our look at beat frequency.